Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the lecture series on smart sensors and devices, and the topic which we are going to discuss now here is resistive thermometers. So as the name itself indicates that it is a temperature dependent resistor type material. So we call this as resistive temperature detectors, that is RTDs. So these are the temperature sensors which utilize any change in the resistance of the material with respect to the temperature in order to measure temperature. So here we are going to focus on the temperature and the resistance of a material which changes as per any change in the temperature. So let us discuss how this type of thermometers works. So initially at the low temperature, the atoms vibrate less, which means that the electrons flow freely. This is at in case of low temperature. So as gradually when the temperature increases, the atoms vibrate more vigorously. So what happens is when this takes place, the electron flow will be impeded by the vibrations. So this will increase the more electric current, and there occurs the increased resistance due to the hindered flow. So what happens here is the atoms vibrate less and the electrons flow freely, and the temperature increases, the atoms vibrate more vigorously, and there is a hindrance in the movement of flow of current which reduces the flow of current. So which means that there is an increase in the resistance due to the flow of this electrons. And the equation here is the resistance at the temperature T is given as R naught into 1 plus alpha T minus T naught. So this is the temperature equation. So where the R naught is the resistance at reference temperature T naught, that is typically 0 degrees Celsius. And alpha is the temperature coefficient of the resistance. So this is how the resistive thermometer works. So there are three types of resistive thermometers. So one is platinum based thermometer, nickel, and the third one is copper. So in platinum type thermometers, the there would be stable and accurate for the measurements can be obtained using platinum type, and whereas in nickel type it is having good sensitivity in industrial settings, and copper, as we know, it is cost effective for low ranges. So these are the three types of resistive thermometers. So, the RTD configurations and its characteristics. There are three major configurations of resistive thermometer detectors. So, one is two-wire RTDs, four-wired RTDs, and three-wired RTDs. So, here two-wire RTDs is the basic setup, and it consists of a simple two lead wires. And here the accuracy is less when compared to other two configuration, and four wire RTDs are having two separate wires for the current flow and to measure the voltage drops. And here in three wire RTDs, we have equal resistance assumption. So four wired RTDs are they're complex in structure, but accuracy is good when compared to the other two types of configuration. And advantages of RTDs are the high precision in temperature readings. They have a good accuracy, linearity, repeatability, stability, and wide temperature range. It can operate over broad range of temperature values, and stability, which means the resistance to drift over time can be obtained. So these are the advantages of RTDs. And the various challenges in RTD sensor types are, the first thing is self-heating. So due to this self-heating, the thermal runaway occurs. So this means the inaccurate temperature measurements will be obtained due to this. And slower response time, so there would be some delay in sensing the temperature changes. And high cost, it is more expensive than other type of sensors. Vibration sensitivity, so which means it will affect the accuracy, and the excitation current would induce some errors if it is not controlled. So these are the challenges of RTD sensors. So there are a lot of applications of resistive thermometers like food processing, aerospace industry, laboratory research, weather monitoring, automotive industry, medical equipments, industrial process control, and HVAC system in the vehicle process. So today's assessment, which of the following is the most common material used in RTDs due to its stability? So as we discussed, there are three types: platinum, nickel, and copper. So where mainly the stability is focused, we use platinum. The resistance of RTD generally, it will increase with increasing temperature. So there is a linearity we have discussed already. And RTDs are best suited for measuring temperatures within which range, that is minus 200 degrees Celsius to 850 degrees Celsius. Thank you.